Welcome, calculus class. This is optimization day 3. It's going to be one example before you guys can start doing the practice problems on your own. The example should be written down for you. We have a Norman window right here. It's a window in the shape of a rectangle with a semicircle on top. If you're going to install a Norman window with an outer perimeter of 20 square feet, what should the dimensions be to maximize the area? So just like all these problems, I need to figure out what I'm trying to maximize or minimize. So that's going to be my primary equation, which is purple. And it says maximize the area, so that's what I want to maximize. Now I'm going to come up with an equation that represents the area of this. So in order to do that, there's a couple of different ways we can go about it. We'll get the same answer either way. Um, I'm not going to do this. I can call this x and y. And then, the area is obviously x times y. But then when I find the area of the circle, to find the area of a circle, I'm going to need the radius because it's pi r squared. And the radius is just going to be, this is the radius, r. Y would just be double the radius. So I'm going to, instead of calling that bottom piece y, I'm going to call it twice the radius, just so that I can have less variables, which is going to make things easier. And then this piece right here is the height. I'm going to call that h for the height. And that's the height of the rectangle, not the height to like the top of the window. Because I don't know if their height and the radius are the same. They do look to be about the same though, and they might be if we're doing this maximization problem, but I don't want to assume that. So that's what I'm going to label the dimensions as. So the area of this whole thing, I'm going to take the area of the rectangle part, which is going to be base times height. So it's going to be 2RH is that area, plus the area of this half a circle. So the area of a full circle is pi r squared. So we just want half of that. So I'm going to do plus 1/2 of pi r squared. You can do it times 1/2 or divided by 2. It's the same thing. So now I have r's and h's here, which I don't want to have two variables. So I'm going to need a secondary equation. Which is going to be my constraint here. Right? Otherwise, if I want to maximize the area, you just make r and h, go to infinity. But the constraint is what's stopping that from happening. So the Norman window has an outer perimeter of 20 square feet. So that's what I'm working with. That's my constraint. So to find the perimeter of this whole thing, let's see. If that is h, this is also h. So we have h plus 2r plus h plus whatever the circumference of half the circle is. We don't need this middle piece right here. So just the outer perimeter. So the circumference, whatever the circumference of a circle is, we need to divide it by 2. So the circumference in general is 2 pi r. So half of that is going to be, so half of that is going to just be pi r. Right? Half of 2 pi r is 1 pi r. So if I want to find the perimeter of this thing, this distance right here is going to be half of 2 pi r, which is just pi r. And then these three walls, h plus h is 2h. And that bottom one is double the radius, also known as the diameter. And so here's my primary equation. We know this has to equal 20. So looking at how this is set up, I think the easiest variable here to solve for is going to be h. There's just one h to deal with, so I'm going to isolate that h. So to do that, I'm just going to move the pi r to the other side, move the 2r to the other side. So those go away. So 2 times the height is equal to 20 minus pi r minus 2r. And divide both sides by 2. So divide by 2. And now we have our primary equation for h. Isolated, 20 divided by 2 is 10. Pi times r over 2, I'm just going to call that pi over 2 times r. Because r is going to be my variable, so I'm going to kind of leave that by itself and have a kind of the constant next to it. It'll be easier for when we do the derivative. and 2 divided by 2 is 1, so we're just going to have minus 1r. And there it is. So now this h right here, I'm going to replace with this expression, which is going to make it look more complicated, but it's going to be all in terms of r, which is going to be good for taking the derivative. So 2r, noticing it now, because I'm going to double it, and there's already a 2 in the denominator, I didn't have to divide all these by 2, because I could have saw that that 2 is going to cancel out that 2, but we'll just double everything again and get back to the 20 pi and 2 in a second. So we have 10 minus pi over 2r minus r plus 1/2 pi r squared. So now when you do this distributing step, boom, 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 the area is going to be 2 times 10 is 20 times r. The 2's will cancel out, so we're just going to get r times pi r, which is pi r squared. And 2r times r is going to be 2r squared. And then we have this plus 1/2 pi r squared. Okay. Let's see here. We do actually have some like terms here. If I have minus a pi r squared plus 1/2 a pi r squared, that's going to be, so I can think of this as, if I want to make it over 2, I can think of this as 2 over 2. Because that's just 1. So I have negative 2 pi over 2r squareds plus 1 pi over 2r squared. So that's going to be a negative 1/2 pi r squared. And so we still have the 20r and the minus 2r squared. And these are actually like terms. I could factor out the r squared, but I'm not gonna. Let's just take the derivative now. Of course, green. So the derivative is going to be 20 minus, let's see, the 2's. When you take the derivative, the product rule, or excuse me, the power rule, the 2's will cancel out, so we just get minus pi r. The 2's, 2 times 2 is 4, so we get minus 4r. And I want to find out where this is 0 does not exist. It's going to exist everywhere. It's just a linear equation, so I just need to solve for r. So I'm going to add the pi r and the 4 to the other side, so everything's positive. It's going to be a positive pi r plus 4r. And then I'm going to solve for r, you just got to factor out the r, and you get pi plus 4. If we're trying to solve for r, divide both sides by 4 more than pi. Let's cancel out, which is very nice. And so the radius is exactly 20 over pi plus 4. Let's see, if I put that in a calculator, 20 divided by pi plus 4, it's about 2.8. Which is, what are we in, inches, feet, or feet? Okay. We're also asked to find the height, because it says what are the dimensions. What should the dimension be to maximize area? So let's find the height. That's just going to be 10 minus pi over 2 times 20 over pi plus 2. I'm just going to round that to 2.8. And then minus r, which is also 2.8. And when I ran this before, I got that the height was actually also 2.8 feet, which I guess isn't that surprising. It does look like the height and the radius are going to be about the same. And when we're maximizing the shape, that is the case. The closer it gets into being a circle or a perfect square, the more efficient or the more the area is going to get maximized. Anyways, so that's it. Any questions, well, let me know in class. If you have any questions, I'd love to hear about it in the comments. Feel free to like, share, subscribe, ring the bell for notifications. Oh, and this video is brought to you by Raid Shadow Legends.